What challenges do F1 engineers face designing Aero today? Imagine trying to design a car that slices through air like a knife, sticks to the track like glue, and still fits within strict rules. That's what F1 engineers are up against every day. The first big challenge is meeting the ever-changing FIA rules. These rules limit how big, how flexible, and what shapes aero parts like wings can have. For example, in 2025, new tests will check how much wings bend under force. Engineers need to find materials that are both light and stiff enough to pass these tests. Next, there's the problem of dirty air. When a car speeds ahead, it leaves turbulent airflow behind it. This turbulent air makes it harder for the car behind to keep grip, especially during overtaking. Even with recent rule changes aimed at reducing turbulence, teams still develop complex surfaces that create lots of downforce but also lots of wake. Balancing these two is tricky because more downforce usually means more turbulence. Another challenge is making sure aero parts work well across different tracks and weather conditions. Some circuits are tight and twisty, while others are fast and open. Engineers use tools like computational fluid dynamics, which is a fancy way of simulating airflow on computers, and wind tunnel testing to see how air moves around the car. They tweak the shapes of wings and bodywork to keep the car stable and predictable, even in turbulent air. Integrating aero with other systems adds another layer of difficulty. The car's suspension, cooling systems, and engine packaging all need space, but they also affect airflow. So, engineers have to design everything to fit together smoothly. Looking ahead, the 2026 rules will push for smaller, lighter, and more agile cars. These cars will have less downforce and drag, making overtaking easier. To do that, engineers will need to rethink aero concepts and develop new active aerodynamic parts that adjust during a race. So, the main hurdles today are creating aero parts that follow strict rules while maximizing performance, managing turbulence to improve racing, ensuring stability across different tracks, using advanced tools to optimize airflow, and preparing for future rule changes. All of this takes constant innovation, precise work, and a lot of teamwork to keep F1 cars fast, safe, and exciting.